Okay, so this is a problem taken from the homework that I've only tweaked a little. And it tells you to suppose that the weight of a newborn fawn is uniformly distributed between 2.1 and 3.9. And it's right off the bat, it tells you that it's a uniform distribution. And uniform distributions, they follow this notation. U, and then A, B. And A represents your starting point, and B represents your ending point. And then it tells you that it's uniformly distributed between 2.1 and 3.9. So that's telling you that their weights of these fawns, they're going to start at 2.1, but they're going to end at 3.9. So in other words, 2.1 is your A, and 3.9 is going to be your B. And then if it tells you to make a graph of this, once you have this sorted out, you can just fill this in. So this is like the basic graph of it. And then there's A, where your distribution is going to begin, B, where it's going to end, and then your height of it, which is 1 over B minus A. And then, so it tells you that it begins at 2.1, so 2.1 is going to go right here. 3.9 is where it ends, so that's going to go here. And then your height, which is 1 over B minus A. So 1 over 3.9 minus 8. And that is going to be 1 over 1.8. And if it asks you for the mean, since it's a uniform distribution, it's going to follow this formula. A plus B divided by 2. And your A is 2.1 plus 3.9 divided by 2. So 2.1 plus 3.9, that's 6 divided by 2, and that is 3. So the mean for this distribution right here is going to be 3. And then if it wants you to find the standard deviation, since it's a uniform distribution, it's going to follow this formula. It's going to be the square root of B minus A squared divided by 12. But once you have your B and your A identified, then you can start plugging numbers in. So your B, where it ends, is 3.9 minus A, 2.1 squared divided by 12. And 3.9 minus 2.1, that is 1.8. So you want to find the square root of, so 1.8 squared. Okay, so I got that. It was 3.24 divided by 12. Okay, so 3.24 divided by 12 is 0.27. So this right here alone is 0.27, but you want to find the square root of that. So you only do the square root at the way end after you finish with all of this. And the square root of 0.27 is going to be 0.5196. And that's your standard deviation. Okay, so for C, it's asking for the probability that x is exactly 2.8. And whatever it wants the probability of x being exactly something for a uniform distribution, it's always going to be 0. And that's because area is the same thing as probability in this one. And 2.8, let's just say that's like right here. 2.8 is like this little line right here. That doesn't have an area, it's just a line. So since it doesn't have an area, it has no probability. And then for this one, it's asking you to find the probability that it's more than 2.76. So let me just translate this: more than, aka greater than 2.76. So you want to find this probability right here. So let's just say that 2.76 is like right here. But you want to find the probability that's more than that. So you're going to shade to the right. So you want to find the probability of everything that is 2.76 or above. But it can't be more than 3.9 because that's where the distribution ends. So again, probability is the same as area equals length times width. So you want to find the length from 2.76 to 3.9. And you could again just do that by subtracting. So 3.9 minus 2.76 is 1.14. So that tells you that you have 1.14 numbers from 2.76 to 3.9. And once you get the length, all you need to do is find your width. And your width is still 1 over b minus a, 1 over 3.9 minus 2.1, and that is still 1 over 1.8. And then you just multiply straight across again. 1.14 times 1 is 1.14 divided by 1.8. And your probability is 0.6333. So the probability of this shaded region is this. And then notice how this one looks different from the other probability questions. It has that line right there. And this line right here, it means given. And whenever you see this little line, that means that you're working with a conditional probability. And with the conditional probability, it just means the probability of one event happening given that another event already happened first. So in this case, you want to find the probability that x is more than 2.4 given that your x's are less than 3.4. So since you're only, so it's on the condition that your x's are less than 3.4. So notice how 3.9 is bigger than 3.4, but because of this conditional probability, you're only working with the largest number you can get is a 3.4. So you're going to have a new b, and that is going to be 3.4. And since you have a new b, you have a new 1 over b minus a. And so 1 over 3.4 minus 2.1 . And that is 1 over 1.3. And the only reason why you have the new b is because of the condition. Well, it's only in this conditional probability because you want the probability that it's more than this, but it has to be less than this. And 3.9 was above that, so that's why the b had to change. So, but once you have that down, your new b, now you can just start finding this probability right here. So the probability that x is more than 2.4. So let's say that 2.4 is right here. You want it to be more than that, so you're shading to the right. And area is still length times width. So you want the length from 2.4 to 3.4. So 3.4 minus 2.4 is 1. So you have a length of 1 times your width. So since you got the new b, you had the new width, and your new width is 1 over 1.3. So 1 divided by, just multiply across. Okay, and that is 0.7692, rounded. So the other question had a condition that the event was less than something, but in this case, it's on the condition that x is more than something. And so this is basically saying to find the probability of x being less than 3.4, given that it's more than 2.4. So you have to work with this here. So 2.4 is like right here, and you're working with the condition that your x's are already larger than this 2.4. So but notice how 2.1 is smaller than 2.4, but this condition is saying that your numbers have to be 22.4 or more. So that's why you're going to have a new a this time. And since you have a new a, you have a new width. So 1 over b minus a, 1 over 3.9 minus 2.4. And that's 1.5. So now you're working with this condition right here. This is a 4, by the way. And so now you can just find your probability of x being less than 3.4. So let's say 3.4 is like right here. And you want the probability that it's less than that, so you're going to shade. Because you want to find this area right here. So area is still length times width. You need to find the length of this shaded region right here. And so you could just do that by doing 3.4 minus 2.4. And that gives you a length of 1. And then you just multiply it with your width. And since there's that new a, you have the new width, and that new width is 1 over 1.5. Then you just multiply and cross. 1 over 1.5. And your probability is 0.667. Okay, and this one it's telling you to find the 28th percentile. So where 28% of the area is. So let's just say that's like right here. Notice how there's like not a number there. There's just how much area is taken up. So this right here is supposed to represent 0.28 of the total area of 1. And this is how I find it. I just put the percentile as a decimal times b minus a plus a. So 28 as a decimal, 28 divided by 100 is 0.28. So just plugging this in, 0.28 plus. Now I have to find what b minus a is. So my b is 3.9 and my a is 2.1. So 3.9 minus 2.1, 1.8. So 0.28 times 1.8, and then plus whatever your a is. And a is your starting point, and that's 2.1. So I'm going to do the multiplication part first. So 0.28 times 1.8 is 0.504 plus 2.1 and that is going to be 2.604. So this tells you that 2.604 is your 28th percentile.